would be define oxidation and reduction, redox in terms of oxygen, hydrogen, gain, loss. Let's begin the lesson with these two pictures. On left hand side, you will see methane gas burning. And on right hand side, there is iron cage undergoing rusting. This is iron cage. Both of these processes or reactions are examples of redox reactions. We have other examples also in our daily life, which are redox reactions. So let's continue our lesson. What are redox reactions? These are the reactions in which both reduction and oxidation takes place at the same time. Let me write. These are the reactions in which both reduction and oxidation takes place at the same time. Takes place at the same time. Now, what is reduction? It is a process or reaction in which either gain of hydrogen or loss of oxygen takes place. It is the process or the reaction in which either gain of hydrogen or loss of oxygen take place. Now let's talk about oxidation. It is the reverse of reduction, which means it is the process or reaction in which either loss of hydrogen or gain of oxygen take place. It is the process or a reaction in which either loss of hydrogen or gain of oxygen take place. And when oxidation and reduction takes place at the same time, we say that it is a redox reaction. This is the first reaction. In this reaction, ZnO has lost oxygen to give Zn. Therefore, we can say that ZnO has undergone reduction. On the other hand, C has gained oxygen. This is C, it has gained oxygen to produce CO. Therefore, we can say that C has undergone oxidation. Zn is written in red. You see it's written in red, which indicates that it has lost oxygen, and CO is in green, indicating that it has gained oxygen. The reaction is an example of redox reaction. Let me write the statement for this reaction. ZnO is reduced to Zn because it has lost oxygen. C is oxidized to CO because it has gained oxygen.
Welcome to Chain of Qualified Tutors. Unlock your academic potential with expert tutoring, from secondary school to graduation level. Master math, science, English, and more with personalized one-on-one guidance. Call or WhatsApp for a free demo session. We offer on-site and online tuition.
Let's do this one. In this reaction, H2S has lost hydrogen to give S. Therefore, we can say that H2S has undergone oxidation. On the other hand, Cl2 has gained hydrogen to give HCl. Therefore, we can say Cl2 has undergone reduction. Let me write. As is written in red on product side, which indicates that it has lost hydrogen, and HCl is in green, indicating that it has gained hydrogen. The reaction is also an example of redox reaction. Let me write the statement for this reaction. H2S is oxidized to S because it has lost hydrogen. Cl2 is reduced to HCl because it has gained hydrogen. Can you solve these examples? PBS is oxidized to PbSO4. Oxidation. Because it has gained oxygen. Gain of oxygen. And H2O2 is reduced to H2O. Reduction. Because it has lost one oxygen. Loss of oxygen. Now, let's see the second reaction. This is a reaction between C and H2O to produce CO and H2. In this reaction, C is oxidized to CO. This is oxidation. Because it has gained oxygen. And H2O is reduced to H2 because it has lost oxygen. Loss of oxygen. Let's see this reaction. This reaction involves oxidation of ethanol to ethanoic acid. C2H5OH is ethanol. And CH3COOH is ethanoic acid. In this reaction, both gain of oxygen and loss of hydrogen are taking place at the same time. This is oxidation reaction. We can count the number of oxygen and hydrogen atoms on both sides of the reaction. Let me write hydrogen atoms, oxygen atoms. On reactant side, there is only one oxygen atom. Let me write one here. While on the product side, it is 2. And for hydrogen on reactant side, there are 6 hydrogen atoms. But on the product side, it is 4. This means that both gain of oxygen, here there is gain of oxygen, and loss of oxygen taking place here. Loss of hydrogen, loss of hydrogen taking place. Therefore, the product is oxidized. Let me write here, oxidized. Define redox in terms of electron transfer. Here's the summary of last lesson. The reactions in which both reduction and oxidation reactions are occurring are called redox reactions. Oxidation is either gain of oxygen or loss of hydrogen. Reduction is either gain of hydrogen or loss of oxygen. Now look at this periodic table and recall the concept of valency. Let me write here valency. This will help you in predicting the charges on the ions. We know that group 1 carries +1 charge. This group carries +1 charge. Group 2 +2. Group 3 +3. Group 4 +-4. Group 5 -3. Group 6 -2. Group 7 -1. Group 8 does not carry any charge. We know that they have complete valence shell, so they do not form any compounds either ionically or covalently. What about transient metal, which are at the center of the periodic table? These are the transition metals. We know that except zinc, they have variable charges. So we will predict by looking at the attached ion. Zn is the only one which carries +2 charge. For the other one, we have to look at the compound. Let's continue our lesson. This is another definition of oxidation. Oxidation can also be defined as loss of electron or electrons. Look at the equation. 2Cl- gives Cl2 and electrons are released. 2 electrons are lost. Here Cl- is undergoing oxidation by loss of electrons. If you look at the equation, then you will see that Cl on reactant side carries minus charge. You see the minus charge, this is the minus charge. And after losing electrons, it will form Cl2. On the product side, Cl2 does not carry any charge. So on the product side, we will consider Cl2 carrying 0 charge. Let me write 0 like this. Remember this point, when there is no charge either on the atom molecule or compound, it means there must be zero charge on it. Reduction can also be defined as gain of electron or electrons. In the above case, you will see sodium plus means it's carrying plus charge on reactant side, and after gaining one electron, it forms Na. It has gained one electron. It is reduction as Na plus has gained an electron. Again, there is no charge on the atom of sodium, which means it is zero. Now let's look at this equation and solve this one in terms of loss and gain of electrons. Here Cl2 carry zero charge. In case of KBr, although there is no charge on the whole compound, but according to the valency concept, K carries +1 and Br -1. Let me write -1 +1. But Cl on the product side, in case of KCl, K carries +1 and Cl carries -1 charge. What about Br2? It does not carry any charge, which means it is zero. Let me write zero here. So in this equation, Cl2 has gained electron and Br has lost electron. Reduction. Cl2 has gained electrons. This is oxidation. KBr has lost electron, or we can write Br minus has lost an electron to give Br2. Cl2 is reduced to KCl and KBr is oxidized to Br2. Now try to solve this one using the above concept. Here we will calculate the charge on Cu in CuO in this way. Now I'm calculating the charge on Cu. Let me put X here. So we'll add the charge of oxygen, which is -2, looking at the periodic table. The whole compound does not carry any charge, so I will write 0 here. Therefore, the charge on the CO will be +2. X -2 is equal to 0. X -2 plus 2, 0 plus 2. So the charge on Cu is +2. Zn carry 0 charge. I've already explained on the product side, the charge on Zn will be calculated by taking -2 for oxygen and 0 for the whole compound. We will get +2. We will also know that Zn carries +2 charge. It carries fixed valency. Therefore, Zn has undergone oxidation by losing 2 electrons. Zn is oxidized to ZnO because it has lost 2 electrons. CuO is reduced to Cu because it has gained 2 electrons. You can give any one of the following reasons for reduction oxidation. It states that CuO is reduced to Cu because CuO has lost oxygen. You can even write lost oxygen here. Or Cu has gained 2 electrons, I have already mentioned. And Zn is oxidized to ZnO because it has gained oxygen. Let me write gained oxygen. For Zn. Zn reacts with aqueous nickel 2 nitrate. This is the reaction equation. Zn solid, NiNO3 whole twice aqueous, ZnNO3 aqueous, NiS. By referring to the equation, explain why this is a redox reaction. Zn has lost 2 electrons. And Ni has gained 2 electrons. So Zn is oxidized and Ni is reduced. Identify redox reactions in terms of oxygen, hydrogen, and or electron gain loss. Calculation of oxidation numbers is not required. Here's a summary of whatever I have explained about redox reactions so far. The reactions in which both reduction and oxidation reactions are occurring are called redox reactions. Oxidation is either gain of oxygen or loss of hydrogen or loss of electrons. Reduction is either gain of hydrogen or loss of oxygen or gain of electrons. In this lesson, I'm going to explain oxidation and reduction in a reaction considering the gain, loss of oxygen, hydrogen, electrons. Consider this reaction. It's between zinc oxide and carbon. The product is zinc and carbon monoxide. In this reaction, zinc oxide is reduced to zinc. Let me write zinc oxide is reduced to zinc as it has lost oxygen. Loss of oxygen. And carbon is oxidized to carbon monoxide. Is oxidized to carbon monoxide. We can write gain of oxygen. We can also explain this redox reaction in terms of gain and loss of electrons. But for this, we should know the charges on the atoms. ZnO and C both carry 0 charges. Overall, the charges 0. What about the charges on individual atoms? Here it's important to know the charge on both zinc and O in ZnO. Look at this periodic table. Here's the periodic table. We know that oxygen belongs to group 6, this is oxygen, so it carries -2 charge. And we can work out the charge on Zn, but we also know that zinc carries +2 charge. But if you want, you can work out the charge on zinc, you will get +2. So we will write +2 here. -2 for oxygen. Look at these working carefully. For ZNO, if we consider X for Zn, and we know that oxygen carries -2, the overall charge is 0, so it will become X -2 is equal to 0, X -2 plus 2 is equal to 0 plus 2. In this way, you will get the charge on zinc also. Now look at the product side. Zn does not carry any charge, so we'll write 0. So the change is reduction, because we will get 0 when -2 is added to Zn plus 2. Zinc has gained 2 electrons. So right, zinc has gained 2 electrons. What about C? C is oxidized. Let's work out in terms of electrons. We know that C carry 0 charge on the reactant side, but on the product side, we have to work out the charge on C by looking at the charge on oxygen, which is -2. So for CO, the overall charge is 0. For C, I will write X. Oxygen carries -2. It should be X -2 plus 2 is equal to 0 plus 2. So therefore, the charge on C will be +2 here. Look at these workings very carefully. C is oxidized to CO because it has lost 2 electrons. Carbon has lost 2 electrons. This is redox oxidation. And this one I've already explained, it's reduction. Now solve this reaction. This equation clearly indicates that Fe2O3 is reduced to Fe. Fe2O3 is reduced to Fe because it has lost oxygen. You can write gain of electron. Gain of electron is also happening here. Now work out the charge on Fe. Oxygen belongs to group 6. It carries -2 charge. We have 2 atoms of Fe, so I will write 2x plus 3 atoms of oxygen. 3 minus 2 is the charge. Overall charge will be 0. So 2x minus 6 is equal to 0, or 2x minus 6 plus 6 is equal to 0 plus 6. We will get 2x is equal to plus 6, or x is equal to plus 6 divided by 2. We will get 3. So the charge on Fe is +3. It definitely has gained 3 electrons. Now we can work out the charges on Al in Al2O3, as we know that there will be no charge on Al. I'm writing it 0. We can work out the charge on Al. So Al is oxidized to Al2O3 because it has gained oxygen. Because it has gained oxygen, or loss of electrons, right? 3 electrons will be lost here. We'll work out the formula charges on Al. You will get 2x plus 3 atoms of oxygen. The same way you will do this, and in the end you will get this. This will be the charge on Al. Describe the use of aqueous potassium iodide in testing for oxidizing agents and acidified potassium manganate 7 in testing for reducing agents from the resulting color changes. In this lesson, I will talk about reducing and oxidizing agents. What are oxidizing agents? Oxidizing agents are reactants or species that oxidizes the other reactants or species and reduces itself. They are also called oxidants. Let me write. Oxidizing agents are reactants that oxidizes the other reactant and reduces itself. They're also called oxidants. They are also called oxidants. What are reducing agents? You can easily define reducing agents in the same way. Reducing agents are reactants or species that reduces the other reactants or species and oxidizes itself. They are also known as reductants. Reducing agents are reactants that reduces the other reactant and oxidizes itself. They are also called reductants. Now, in the periodic table, you will find reducing agents on left hand side. We know that these are metals. Here's a staircase line. These are metals. They are reducing agents. So metals are good reducing agents. This is because they have good tendency of losing electrons or simply oxidizes themselves. Metals are good reducing agents. On the right hand side of the periodic table, we will find oxidizing agents. And we know that on the right hand side, there are non-metals. Here we are having non-metals. Let me write non-metals. The good oxidizing agent are good oxidizing agents. Therefore, non-metals have good tendency of accepting electrons or gaining electrons and oxidizes the other reactants in a reaction. Now, following is a list of some oxidizing and reducing agents. See non-metals, they are oxidizing agents. We have N2, O2, etc. And for metals, we have metals like Al, Mg. We have some non-metals also acting as reducing agents like carbon, hydrogen. But in your syllabus, KMNO4, which is acidified potassium manganate 7, is included among the list of oxidizing agents. This is KMNO4. The color of potassium manganate is purple or pink. This is potassium manganate. Potassium manganate. Right, 7. The number in Roman indicates that the manganate ion in this compound carries +7 charge. It's +7 charge. You can see the test tube with purple color. It is potassium manganate 7. During its reaction, it will oxidizes the reducing agent, and as a result, the color changes from purple or pink to colorless. So we'll have no color here. After oxidizing other reactant, we'll get colorless solution. This is colorless. Before this pink or purple. We write pink or purple. The charge on the manganate ion also changes from +7 to +2. +2. This test is used to confirm the presence of a reducing agent in a reaction mixture. Potassium iodide is included among the list of reducing agents. This is a potassium iodide. Potassium iodide solution is colorless. This is potassium iodide. Potassium iodide is colorless. You can see the test tube with no color. There's no color in it. It is potassium iodide. During its reaction, it reduces the oxidizing agent. As a result, the color changes from colorless to brown. After reducing other reactant, color changes to brown, right? So right here, brown solution. Here the charge on the iodide ion is in potassium iodide is -1. It's -1 here. It will changes to 0. Adding belongs to group 7. If you don't know where these charges are coming from, then watch my videos for ionic bonding. This test is used to confirm the presence of an oxidizing agent in a reaction mixture. Now let's find the oxidizing and reducing agent in the above reaction. In this reaction, in this reaction, PbO is reduced to Pb. PbO is reduced to Pb as it loses oxygen. Also, the charge on Pb changes from +2 to 0. Charge is +2, changes to 0. As it is reduced, which means it is oxidizing the other reactant. Therefore, PbO is the oxidizing agent. PbO is oxidant or oxidizing agent. CO is the reducing agent. CO is oxidized to CO2. Oxidized to CO because carbon has gained oxygen. Also, the charge CO oxidized to CO. The charge on carbon changes from +2 to +4. So CO is reducing agent or reductant. In this reaction, H2S is losing hydrogen to give S, which means it is oxidized. H2S is oxidized to S. Cl2 is reduced to HCl. We know that H2S is oxidized to S because it has lost hydrogen. Cl2 is reduced to HCl because it has gained hydrogen. So H2S is reductant as it reduces Cl2 to HCl. Cl2 is oxidant or oxidizing agent because it oxidizes H2S to S. Tartaric acid is reduced to succinic acid by acidified aqueous potassium iodide. What color change would you observe in the reaction mixture when this reaction is carried out? Look at this again. Now you can write the answer easily. Colorless to brown. Colorless to brown.